Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about higher derivatives when we're working with implicit functions. So in the previous video, we did talk about higher derivatives, but we only looked at functions that were explicit functions. And by that, I mean that the dependent variable was isolated, or in other words, the dependent variable was written in terms of the independent variable. So we had y equals and then the function. In this video, I want to take a look at finding higher derivatives when you have equations where it's not an explicit function. So this would be called an implicit relation. And we can still find first derivatives, second derivatives, third derivatives, and so on. So let's take a look at finding the second derivative in this example. So if you're asked to find the second derivative, we're going to start off the same way we did in the last video. We're going to find the first derivative. So we're going to differentiate implicitly, which means we find the derivative of every single term with respect to x, remembering that when we're dealing with a y, it's a function of x. So we have to remember that and use our power rule. So the derivative of our first term will be 12x squared plus 2 times the derivative of y squared is not simply 2y. It would be 2y times the derivative of y. We don't want to forget that factor. Equals the derivative of a constant is 0. Let's just clean it up. And then what I'm going to do is I'm going to isolate dy dx. So I'm going to subtract 12x squared from both sides, and then I'm going to divide by 4y. So that's my first derivative. And now what I want to do is find the second derivative. So I differentiate my quotient. This function is a quotient, so I need to use my quotient rule. So my quotient rule says the derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which is dy dx, all over the denominator squared. And I'm going to clean this up. So that will equal negative 6xy plus 3x squared dy dx over y squared. So we found the second derivative. However, we have a first derivative in our answer. And when you're asked to find these higher derivatives, you just want to express it in terms of the variables, not other derivatives. So we're going to replace dy dx with negative 3x squared over y. So I'm just replacing dy dx with this. Let's clean that up. We're still not done because we have a fraction in our numerator and this isn't considered simplified. So what we're going to do is multiply numerator and denominator by y, and that will take care of that problem. So remember, when you multiply an expression by something, you have to multiply each term. So when I multiply my first term by it, I'll get negative 6xy squared minus, when I multiply this term by y, the y will cancel, and I'll have negative 9x to the fourth. And in my denominator, I'll have y cubed. This is how you should express your second derivative. Not in terms of the first derivative and x and y, but just in terms of x and y. And that way, then, if you were asked to evaluate your second derivative at a particular point, you just put the x and y values in. So when you're working with equations where your dependent variable is not isolated, it does get more challenging in finding higher derivatives. But just find the first derivative, then differentiate that to get your second derivative, and then replace any first derivatives with this expression. As always, my recommendation is that you practice these questions in order to get good at them. And you should now be able to differentiate any type of algebraic function, whether it involves products, quotients, powers, whether it's implicit or explicit, and whether you're finding first derivatives, second derivatives, and so on. There are more derivative formulas to follow, and I will get to those down the road a little bit. What I first want to do is take a look at some applications of the derivative. How do we use the derivative? So the next series of videos is going to be on applications. So when you're ready, join me then. Take care.